Number 22, a ball is dropped from a height h without air resistance. If the ball falls a distance of h over 2 in a time t, how much time is required to fall the remaining h over 2? All right, so we have a ball, and it's full. Let's move this over a little bit. So we have a ball, and it's falling a distance of h when it falls all the way to the ground. So this situation we're calling situation 1. And that ball at the halfway point has a height h over 2. And then when it falls the second height, again, it's h over 2 again. But we're going to call that our final time. And the time to drop the first half they gave us was time t. All right, so that's a given. And we're going to call this situation 2. The total time in situation 1, we're going to call t plus t final, because that adds this and this together. All right, so the trick with this problem is that you need to use the equations where v naught y is going to equal 0, and we need to set the upward direction as being positive. All right, so let's use equations where v naught in the y direction equals 0. So the equations we're going to use is y equals y naught plus v naught yt plus 1/2 gt squared. Right? And these we can eliminate the initial velocity. So we're left with y equals y naught minus 1/2 gt squared. And we're saying it's a minus because, again, we're saying the upward direction is positive. So when it's falling down, it's negative. So we can just say minus g, minus 10. All right, so for the first situation, let's look at that. Using this equation, we're going to say its final height would be 0. And that's going to equal its initial height, which was h, minus 1/2 g times the time. And the time we said was t plus t final, and we have to square that. Right? So, all right, let's take everything, let's leave h be by itself and add 1/2 quantity t plus tf quantity squared to both sides, and we're going to get h equals 1/2 t plus tf quantity squared. To get rid of the half, we'll multiply by 2, so we have 2h equals quantity t plus, we lost a g somewhere, 1/2 g t squared, 1/2 g t plus tf squared. Now we divide by g, we have 2h divided by g equals t plus tf quantity squared. All right, so now for the second scenario, again using the same equation, we're saying its final height, when it gets to here, is h over 2. And that's going to equal its initial height, which was h, right? Minus 1/2 g, and the time they gave us to that was t squared. we can subtract h from both sides. And then multiply by a -2. And that's going to give us -h plus 2h equals gt squared. Or t squared equals h over g. All right, so here's the little fancy trick here. T squared equals h over g. So we can plug in t squared wherever we have h over g. So we're going to have 2t squared equals t plus tf quantity squared. What we could do now is square root both sides, which will give us, or let's just flip this around again. So we have t plus tf quantity squared equals 2t squared. And if we square root both sides, we have t plus tf equals the square root of 2 times t. So if we're solving for the final time, we have the square root of 2t minus t. All right? So the square root of 2 equals 1.41 t minus 1t. The final time is going to be 0.41 t.